Hi everyone and welcome back. In today's edition of Design and Analysis videos, we're going to be looking at a chi-square test of independence. If you remember, chi-square tests are non-parametric tests that are used with nominal data, that is categories. Things can go in one bin or the other. And with a chi-square test of independence, we're looking at the possible relationship or independence of two separate nominal variables. So you might have something like gender, and we might have male, female, transgender, and other individuals, and whether they differ in smoking rates, smokers or non-smokers. What we end up doing is combining these two factors into a table of data that looks at frequencies, that is the number of people in each box or category. And what we want to do is see if these concepts have something to do with each other or whether they don't. If the concepts have a relationship, we won't see the same pattern across one of the columns as we do for the other. If the relationships are non-existent and the factors are independent, we will see a similar pattern for the groups. Thus, chi-square test of independence is about pattern recognition. And again, it's based on frequencies or probability. We are comparing what we expected to happen to the counts that we actually have. So let's take a look at SPSS to figure out chi-square test of independence. You may remember that when we did a chi-square goodness of fit test, we came down to non-parametric tests, legacy dialogues, and chi-square. But the really interesting thing is for chi-square is we cannot do the other kind of chi-square here. This will work for a single variable if we wanted to look at the counts and see if there was differences in something's popularity. But if we want to look at the potential relationship or independence of two nominal factors, we have to come up to descriptives and then this button called crosstabs. Crosstabs can do other things, but we're going to learn how to use it for a chi-square test of independence. When you go to crosstabs, we want to put one of the nominal factors in for rows and the other one for columns. It really doesn't matter which one you put where. It's just important that you've stuck one in each of these boxes. In the current example, we're going to see if there is a relationship between people's gender or sex and whether or not they consider themselves a sports fan. Again, each of these is nominal. Each person can pick one category here, and each person can pick one category here. Under statistics, you want to make sure that you've selected chi-square. We can do other things. We can do effect sizes, some other things for different scales of data. But if we're using nominal data, we want to pick chi-square and continue. We also want to go to cells and make sure that we have these boxes checked. When you first ask it to run a test, it will only have observed. We also want the expected values. What do we think was going to happen? And then the row, column, and total percents, so we can figure out how many people or what percentage of proportion of people actually picked that option. The last thing that we need to do is make sure we have this box checked to display a clustered bar chart. This will help you make sense of the chi-square analysis once you run it. Once you have these three things, statistics, cells, and display bar charts, click OK. And we will see with our crosstab data the descriptive information first. Right? The first box that we get tells us how many people answered both of these questions. It tells us if anyone skipped one of those questions, so we can't use them in the analysis, and the total number of people in our sample. So again, total sample, missing instances. Here's the people that filled out the questions for this particular analysis. The next thing that it does is give you the counts and percentages, a whole bunch of different percentages, for the number of people that actually provided a certain answer. So in this data set, when we asked about sex, we have male, female, and no individuals who selected transgender or other. And when we asked about whether they're a sports fan, we had people saying yes, here's the counts by male and female, or no, here's the counts by male and female. Right? When you are reporting a chi-square test, these are your descriptives. You need to at least provide the counts or the frequencies that you observed. Count is frequency observed. It's also helpful to report the frequencies that were expected. Okay. Notice that these do not add up to 25% of people in each category. The frequency that we expect is based on the number of people in that group divided by the total in that variable. So here, right, we're looking at how many people out of the ones possible do we expect to have those kind of counts, right? So if we look down at what the chi-square test is giving us, the other thing we need to report is our inferential test. This is actually testing the hypothesis about whether things are linked or related, that's our research hypothesis, or whether they are independent, that's our null hypothesis. So we've established an alpha level of 0.05. We could go to the tables in the back of the book and figure out what's the chi-square value that we need to reject the null hypothesis. And this first line here with the Pearson chi-square, here's that Pearson name again that we saw in correlation, is the data that we want. For the purposes of Psych 2231, you won't need these other options at the bottom. Right? It's giving us a little footnote to see if any of our cells have too few people. Remember that with chi-square, if we don't have at least 5 people in each box, the test gets pretty sketchy and we don't want to trust it. So if you see that one or more cells has less than 5 people in it, you'd want to report that, or maybe get more people in your sample. Our sample size, however, is pretty large. So we're going to look at reporting this chi-square value. Our chi-square is 7.702. We might round that to 2 decimals. We were to report 1 degree of freedom and our total sample size of 224. And we would also need to report our probability value, our p-value here. Again, if this is less than 0.05, that means we're in the critical region. We're beyond the cutoff that we said, hey, that's interesting enough, I want to pay attention. That's significant. And so when our chi-square value is large and our p-value is below our cutoff of 0.05, we would reject the null and say there does seem to be a relationship between these two variables. Now, what chi-square can only tell us is that a difference exists. It really cannot help tell us the pattern. So after you've made your decision, you still have to look at the data and figure out how to explain this to somebody in English based on the concepts we have, right? What's your sex? Are you a sports fan? How would we explain what we're seeing to the everyday person? Okay? There is a relationship between these two things. If there was not, the pattern here would mimic the pattern here in terms of its proportion or percentages of how many people picked each category. What we're seeing, since there is a relationship between these two things, is that the pattern differs for gender rates and whether someone was a sports fan or not. So we could see for people who said yes, right, there were always more females in both groups, but when people said yes to being a sports fan, there were relatively more males than when people said no, or there were relatively less females in the I'm a sports fan group than there were in the I'm not a sports fan group. So you might explain this by saying a smaller proportion of females was a sports fan than was not a sports fan. Or you might say males are more likely to be a sports fan than not when compared to females. Chi-square test of independence is one of the trickier ones to describe because you've got to think across both factors to describe whether there's a match in pattern. Sometimes it might help you to reverse those factors and how you listed them and taking a look at the graph. So the first time we put sports fan here and sex down here, I'm going to reverse that this time and put sports fan on the bottom and sex on the top and see how that changes my bar chart. It won't change my chi-square, but maybe if you look at it this way, you can see that males have a higher proportion of sports fans than not, and females have a lesser proportion of sports fans. Okay? So if we think about, again, sometimes flip those categories and think, how could I explain this in a way that makes sense? Right? Males are more likely to be a sports fan than not. Females are more likely not to be a sports fan than to be one. So you think about how you could describe those patterns. You can see here that these are not parallel. Right? The pattern here for males is different than the pattern is for females. If we had it this way, that was more of a discrepancy between no's and yeses in terms of gender. Or if we put gender at the bottom, we can see males are more likely to be a sports fan, females are more likely not to be a sports fan. Hopefully, this gives you an idea about how to start calculating chi-square test of independence. Ideally, we would also be working out how to do this by hand, but if for time's sake this semester we didn't get that far, at least you can use SPSS to be able to look at the relationship, or at least potential relationship, between two nominal factors. Thanks!